Now, yeah, we are live now.
Should we wait for... The chairman for this session are Professor Rupaban Subadar and Dr. Swagata Mandal. Dr. Rupaban Subadar is currently working as a professor while holding the position of HOD in the EC department, Nehu, Shillong. He completed his PhD from IIT Gauhati. He is a recipient of GIP QIP scholarship from pursuing his PhD at IIT Gauhati. His field of expertise is in wireless communication or theory of wireless communication. He has approximately 24 years of professional experience and has published more than 38
আহো
numbers of articles.
ঠিক আছে
He has successfully guided 5 PhD scholars. Apart from being the HOD of the department, he is also an in charge in the campus development department in Nehu. Dr. Swagata Mandal, he is uh, the assistant professor in the Department of Electronics and Communication Engineering, Jalpaiguri Government Engineering College, West Bengal. Dr. Swagata Mandal has completed his doctoral research on development of FPGA-based error-resilient self-triggered readout chain for CBM experiment at the Variable Energy Cyclotron Center, Kolkata in the year 2017 and was a postdoctoral fellow at the School of Computer Science Engineering, Nanyang Technology University, Singapore. He is the recipient of the DGFS PhD Fellowship for pursuing PhD in the area of engineering science from the Department of Atomic Energy, Government of India in 2013. He had received fellowship from different prestigious conferences like VLSID, ATS, ISVLSI, and so on. His research interests are memory computing, memory computation, VLSI design, embedded system design, fault tolerance system design, and hardware cryptography. So now I request Professor Rupaban Subedar and Dr. Swagata Mandal to chair this session. Thank you.
good morning
Good morning, everyone.
Uh, so I would like to welcome you all to this particular session. So I would also like to welcome my chair, okay, session chair colleague, Mr. Swagata Mandal, the Professor Swagata Mandal, to this particular session. So in this particular session, I have seen we are having total 7 number of papers and we are having 90 minutes. So I think we can give 10 minutes time to each of the presenter and then the remaining time for the question and answer and as well as for changeover. So the first paper for this particular session is miniaturized dielectric disc-loaded monopole antenna. So I request the presenter to start the presentation.
Yeah, Masud, you can start. Yeah.
Yes.
Please share your screen and then start. Masud, you can please start.
Yes. Yes, sir. I'm just, I just, I just shared the. Is this visible?
Yes.
Yes, visible.
Yeah,
Okay.
absolutely fine. Yeah, you can start.
Okay. Uh, Myself, Khan Masud Parvez, on behalf of other co-author, Dr. Sheikh Moinul Haq and Lakshmikant Minas, I am going to present a research article on my current research area, that is miniaturized dielectric disk loaded monopole antenna. And I am the research scholar in the university and the earlier university Newtown campus, and I will discuss about the presented topic. Here the outlines. First up, I want to draw some attention on the miniaturization, then common miniaturization technique, and then a single dielectric loaded monopole antenna, then double dielectric loaded monopole antenna, application and conclusion, and end with reference. First of all, I want to some basic idea about the miniaturization. To understand the miniaturization in better way, I have designed here two cases, for case one and case two, and here I presented a slot antenna. Okay, and L is the length of the slot. Uh, L is the length of the slot. For first case, for first approach, L is the slot length, and it is radiate at 2 gigahertz. And for the second approach, length is same, but it radiates at 1 gigahertz. That means the length of the slot is equal, but the frequency is reduced. That means we are not changing the antenna size, but we are changing the resonant frequency. It can be defined as the miniaturization. Here, for an example, I have shown the for the slot antenna, but for my paper, I will uh, draw the entire picture for the monopole antenna. And here for case 2, the slot length is L1 and it's radiated at 2 gigahertz. Whereas for the next approach, slot length is L2 and L2 is greater than 1 gigahertz. That means we are reducing the size of the slot. And that is basically antenna here. And but antenna is resonate at 2 gigahertz. Then what we can conclude from this case 2, we are reducing the antenna size, but the antenna is resonating at the its original operating frequency. Then it can be also described as the antenna miniaturization. For my paper, I am taken the case 1 where I can understand the antenna size. Here I have shown the slot antenna, but for my case, I will show for the monopole antenna. The miniaturization, these are some common techniques for the antenna miniaturization. Increasing the electrical path length using the hyperconductivity and high permeability substrate, modifying or optimizing the antenna geometries and shape, antenna can be miniaturization. And for my motivation, for my motivation is to design the miniaturized antenna in simple and the effective approach. And other also important motivation is to minimum affect the antenna basic parameter like return loss, radiation pattern, input impedance, plot, and the efficiency. For my paper, here I have shown the two figures. First one is the monopole antenna, which is considered as the reference antenna, and the next figure is considered as monopole antenna loaded with the single dielectric disc, as it is shown in the figure 2. The antenna length, which is defined here as L1, and the diameter of the diameter of the monopole arm, which is defined as D1, is constant for the figure 1 and figure 2 and rest of the paper. Now, now we show the effect of the miniaturization. In the next slide, I also better realize the effect of the miniaturization. I also added here a equivalent circuit, which is shown here for the figure 3. In equivalent circuit, L1 and L2 represent the monopole arm, and the L2, L2, R2, and C2 is defined as a single dielectric disc. And whatever I have defined for the miniaturization or the basic concept, here in the figure 4, if you look in the figure 4 and particularly at A, then here you find that reference antenna is resonate at 1.99 gigahertz. This is the antenna. This is the quarter wave antenna, which is resonate and the quarter wavelength. And up to loading with the single dielectric disc, the resonant frequency is shifted towards the left side in the return loss plot, and it's resonate at 1.49 gigahertz. And for the equivalent circuit, I also take measure the return loss characteristics. And in this case, in the figure B, you can notice that the return loss for the HFSS simulation and equivalent are almost equal to each other. And one thing I need to mention here, that for the dielectric disc, I have used the RT-Deroid 6010 LM, which has the permittivity of 10.2 to design this antenna. And the next motivation is to when we start the design of the miniaturized antenna, and our next motivation is to minimum effect to the antenna basic parameter like radiation pattern or radiation characteristics. Here I have shown the radiation characteristics. Here E plane and H plane I have shown, and the simulated and measured radiation pattern are shown here, and the difference between the copole and the crosspole are below the acceptable value, which is 20 dB. And both the radiation characteristics behave well, and it is good for the wireless communication system. And when we try to miniaturize an antenna, then the antenna is suffer from the low input resistance. That's why I have included here the reference impedance plot and the loaded and loaded input impedance plot. If you notice the impedance plot seriously, then you will find that in F1, which is for F1, which is defined as 1.99 gigahertz frequency, and the black color, which is basically the reactance, touch the zero axis, where is corresponding input resistance, which is defined through the blue line, is touch the 50 ohm input impedance. And for the loaded approach, at 1.49 gigahertz, the red line, which is defined as the resistance, is also touches the zero axis of the input impedance plot, and its corresponding resistance, which is defined as green line, is 50 ohm. That means we can conclude that input impedance pattern does not affect any effect on the miniaturization. In the next approach, single dielectric disc is attached with another single dielectric disc, and it is just behind the monopole arm, and it is not clear picture. We will show the fabricated prototype in the later version, that the picture will be clear. And the figure 8, again, the circuit model for the monopole antenna with double loaded dielectric disc, and two parallel dielectric discs is parallelly placed by L2, R2, and C1, and L3, R3, and C2. And the effect on the return loss defined as figure A, the normal quarter wave monopole antenna is resonate, as I have previously mentioned, is at 1.99 gigahertz, but in this case, it is resonate at 1.31 gigahertz. And then you can clearly identify the frequency reduction comparison to the normal monopole antenna. And the percentage of frequency reduction is 34%, around 34%. And the response of simulated and equivalent circuit are almost equal match, and it can be presented in figure 9 and at B. And here again, I have represent here the radiation characteristics for the double dielectric disk loaded monopole antenna, and it is clearly shown that the difference between copole and the cross pole are below the acceptable level, that is 20 dB. And this is the current distribution plot for the double dielectric disk. Here you can show the monopole attached portion is towards the upwards, and just below the other side are on the opposite direction. And this is the fabricated prototype for double dielectric disk loaded monopole antenna. This antenna can be replaced at sharp field antenna in the automobile sector. And sharp field antenna is covered with dielectric material. That's why it can be integrated as a sharp field antenna, which is much lower, much miniaturized antenna can be replaced on the sharp field antenna. That's all. This is my reference I have used for my preparing the manuscript. This is all the somehow it is okay. And any questions? I'd like to answer.
So, audience, please, if any questions.
The session is open for question now, question and answers.
I think.
So I have one question.
Okay.
Swagata, you are asking something?
No, sir. You can ask. Yeah, I am not asking.
Okay. So I have one question. Okay, you have shown the equivalent circuit for both the antenna. So how you are calculating the parameters of this equivalent circuit?
I have used NIAWR simulation tool to calculating the antenna L, R, and C, and I match the return loss and phase response with the HFSS tool. So basically, I have used NIAWR software to calculate the L and R basic values of the circuit component.
Okay. And the validation you have done by measurement. Validation of your
Yes.
antenna you have done it by the measurement.
Yes.
Okay. What do you, Sagata ji?
So, just one question, Masood. So, have you started the
Yes, yes.
fabrication of it? Is fabricated already?
I have already fabricated. I have shown you the fabricated photo. Can I go to that slide?
Okay, yeah.
Yes.
Okay, these are the current.
This is this
one fabricated.
This one is the fabricated.
Okay. Yeah. Thanks. So I think if there is no other question, then we can thanks Masud for his nice presentation. And now we can move to the next presenter.
Thank you, sir.
Yeah, yeah. So, sir, can I call the next one?
Yes, sir. Yes, sir. Please.
Yeah. So then, paper ID 31, design of optimum NBTLU using crossbar gate. I think the presenter, name of the presenter is this one, Dr. Orindam De.
Yes, sir. Presenting.
Okay.
Sir,
So
am I
please start.
audible?
Yeah, you are audible, but your screen is not visible. Yeah.
Yes, sir. I'm trying to share the screen.
Yeah, it's visible now.
Okay.
Yeah.
So you can start 10 minutes
Yeah.
for your presentation.
Okay.
Try to be brief. Okay.
Okay, sir. Okay. Myself is Dr. Arindam Dey. I'm presenting the paper on design of optimum NBTLU using crossbar gate. These are the co-authors of my paper. I'm coming to the outline of my talk. First, we narrate about the objectives, then literature review. We introduces the optical design parameters, and then we come to the design aspects that we have made, and then conclusion. So first, coming to the first point, then why we need a optical circuit, because the normal circuits we have normally seen that is based on electrical circuits, which passes electrons. But if we have a circuit that passes photons, then the speed of the transferring data can be very high. So like a optical mouse, which has a high sensitivity and passing of information very fast in light speed. So we are focusing on that aspect, that if we can design some circuit which can take the optical signals and can give the response as well or not. Now, the first question comes that while designing an optical circuit, is there any possibility to, what are the devices actually, that means are there to design the optical circuits? For example, designing a Boolean circuit and or NAND NOR gate, these are the gates are there. So for optical circuits, the well-known gates are like TOAD, which stands for Tetrahertz Optical Asymmetric Demultiplexer. There is another device called Mach-Zehnder Interferometer. It is sometimes pronounced as MZI, and crossbar gate. Then optical fibers are there. Actually, optical fibers are used to connect between these devices. So I should not specify that exactly this is the logic device. If I say, then TOAD, Mach-Zehnder Interferometer, and crossbar gate, these three are logic devices, optical logic devices, and optical fibers are used to connect between them. Now, here I have given that the necessity of building an optical circuit. Just I'm going through some of the sentences here. That we are familiar with the electronic circuits, but new concept in circuits is optical circuit. As the name suggests, optical circuits involve the use of light, or precisely photons. Already the same things I said. Compared to electronic circuit, we can see photon as light, but it is impossible for us to see electricity. Optical circuits have the capability to provide unmatched speed with the information processing. And in that part already I said previously that due to the presence of photon, the speed goes up. Optical circuits don't lie fully in either optics or electronics. It has a lot of relationship with photonics, as optical circuits stand as an important subject in photonic degree. With the growing importance of photonics and the electronics field, a new branch named optoelectronics also has come. So, and also in present scenario, there is in the quantum computing domain also, they are merging quantum computing with the optical computing. So opto-quantum hybrid technology they are developing, because quantum has a superposition state and optical electronics also based on photons. So they can be, the hybrid technology can be developed. So whether some improved devices or improved logic can be designed or not, that is also an open area of investigation. And the final point is the optical circuits are generally used as photonic integrated circuits. It is termed as PIC, just like IC, which we commonly uses. PIC is made of indium phosphate and lithium niobate, unlike silicon and germanium. Okay. Now we are coming to our work specifically. Uh, our main focus of the work was to design the circuit. We focused on designing the ALU, the arithmetic logic unit. That means there is an important role that plays in the computers. That way, that the all optical design we can make. And here the main devices that we have used here, that is crossbar gate. Some parameters over which we have focused, like can we design the circuits with minimum number of crossbar gates and the interconnects. And also we have simulated the circuits in the optical circuit simulation tool, OptiBPM. So I am coming forward to that point quite sometimes later. These are the literature review. That means that some of the works already being done in this optical domain in recent past. Like optical, in the first point, it is said that optical design using asymmetric demultiplexer using that, reconfigurable logic operation using the toad. Then Mach-Zehnder interferometer based adder circuit, Mach-Zehnder interferometer based Carry-Look adder circuit, Boolean expression generation using the optical devices. Then another work is there, the large scale synthesis. Here the work in 2018 it was done, that when we have some big circuits like some 1,000 input variable function, for small circuits we can simulate using we can design manually. But when we have a circuit having thousands of input lines and million of gates, then how to design? So it's a graph based algorithm here that was presented, that how BDDs can be effectively used to design the circuits. Coming to our work, so this is the particular design of the crossbar gate. These A and B are the inputs and X is a control. So if X value is 0, then in this expression we can get that this A is the output, because XB is value is 0. And here also, that means M is equal to A. That means in this port the output we are getting if X is 0. But if X is equal to 1, we will be getting output from this port. Okay, this is a typical design of crossbar gate, and the same information we have given here a bit mathematically, and it maps the function. This crossbar gate map the function, Boolean function, from B3 to B2, because B3 means here the 3 inputs are there, A, B and X. Though X is a control input, still we are specifying as input, and 2 outputs are there. Normally, before showing the design of ALU, here the rough design of normal 1-bit ALU, normally we see that it contains a full added circuit, logic unit and a multiplexer, and it performs several different operations based on the inputs given. Now, before showing our design, 3 parameters we have to specify here, because when we are designing an optical circuit, some costs are being involved. Those costs are being evaluated in terms of number of gates present in the circuit. Number of gate means the number of crossbar gates present. That is termed as optical cost. Actually, this is termed as optical cost. And delay stands for how many clock cycles we require, minimum clock cycles, to get the first output. And that parameter is denoted by delta. And optical cost is denoted by number of crossbar gate that are being used. But apart from the crossbar gate, 2 more devices are required, as I mentioned earlier, that to pass the signal, beam combiners and beam splitters. Combiners actually combines the signal when multiple optical signal comes. For example, when I am throwing some laser lights, so all the lights, this amplitude to be added. So these beam combiners are used to add amplitude of all the different wavelengths, and beam splitters used to split the wavelengths into different wavelengths as per the requirement. Mostly it is splitting the wavelength, signal strength by 50-50, but sometimes depends on the splitter property in which way that it will split. Now, the first, as we shown that this is the design of a crossbar gate. Now I am coming to all the 3 modules that are required to design an ALU. That the first module is that arithmetic block. Here you can see these are the crossbar gates. These are the crossbar gates. These are being interconnected, and these slash symbols represent these are the splitters that are being used to split the signals. Okay, so this is the design of arithmetic block, and for we have tested this arithmetic block in this OptiBPM tool, and we have checked that for the different operations that it should perform, whether it exactly performing or not. So we seen that the output was satisfactory, it was performing the same. Then coming to the ALU block, logic block, that here also the block we have designed here, you can check that 1 2 3 4 5 6 7 8 9. So 9 crossbar gates are required, and here also you can check that this is the beam splitters are required, because when signal is passing from B, I require the signal to be passes through this device and also as well as to this device and also this device. So that's why splitter is being used. But when we require to recombine the amplitudes, then this beam combiner is being used, because this output and these outputs are recombined over here and passes through over here. Okay, so this is the two modules we designed. First module we shown, that is arithmetic module, and the second module is a logic module. Then, and for the logic module also we have tested the 4 different operations: A is or B, A into B, A or B, and A XOR B. And also we checked that this was the performance was satisfactory in terms of the desired output. Now the final logic module was 1-bit multiplication divisional circuit block, and also here the same the property we have used. And in our designs, we tried to make the design as small as possible, so that the requirement of hardwares and the optical devices and optical combiners are minimal. Okay. Now this is the proposal of the 1-bit ALU, that how it can looks like in terms of crossbar gates. We checked the here I am showing that this is the 4-bit design of the ALU when we combine the different modules in one go. So this is one module, this is another module, this is the third module and fourth module. So one complete design of the module is shown here, that is called 1-bit module, and this module is generalized in 4-bit module terms here, which afterward is generalized in n-bit module terms here. So this is the circuit we tested up to 4-bit module, and also 16-bit module also we have tested whether it is performing all the arithmetic logic operation using the optical signals or not. We have seen that it is performing well. We could not test n-bit. This is not possible for us to check the n-bit. That's why we generalized the circuit and we have shown it here. And also for the n-bit circuit, we calculated that how many ancilla inputs are required. Actually, ancilla input means whether some additional lines are required or not. We checked it for each circuit. We need for 4-bit ALU we need 6.
Your time is almost over. Your time is almost. Please speak.
Oh, 6. So just 1 minute I am taking. 6 additional ancilla lines required. For n-bit it is n plus 2. For optical cost it is 136. It is 34n. Optical delay is 20 delta. It is 5n delta. And this is all about our work. We focused on designing an n-bit ALU with minimum number of crossbar gates. We tested the circuits using the OptiBPM tool to testify whether the exactness of the design. Thank you very much for all you for giving me the time. Thank you, sir.
Thank you, Arindam Deji. So now the session is open for question answer.
Okay, sir.
So any question from audience? Seems that there is no question from audience. So I have one question actually.
Yes,
So basically, that means your ALU, okay, if you apply this particular method, it will be a faster, much faster, okay?
We expect.
Hello?
Yes, sir. We expect that it to be much faster.
Yeah. But what about the memory device? Your memory device is going to support your ALU?
Sir, that parts we are working, because your question is truly correct, that when we are designing an ALU, that whether other supporting device will work in synchronization with ALU or not. So, sir, we are focusing on that part also, because designing only the ALU will not be the final thing that will solve the problem. So we are also considering the same issue in our present scenario, that whether the memory devices, how I can merge or synchronize the memory devices with these ALUs.
Okay. So if it is there in your, that means research work, okay, then it's fine. Because
Yes.
otherwise the complete system will not work. I
Yeah,
feel
yes.
it's my
Correct.
observation.
Correct,
Okay.
sir. We also designed the flip-flops, how the flip-flops can work. So that prototype also we have designed. And
Okay.
that part already we have formulated, the design of flip-flops. And sir, we are working further on it.
Okay. Over to you, Swagataji.
Yeah. Yeah, Arindam sir, just one question that you told that obviously it will faster the system. That's okay. Faster computation is okay. But what about the power consumption? Is it means increase the power consumption or not at all? Means, or if it is increased, how much compared to
Sir, power
traditional?
consumption means as it's based on the optical signals. So
Yeah.
power calculation parts we have not done that part, but we need to
But
go
though
through.
it may be optical, it's okay. But allied circuit means, as sir is telling, like, the memory and other IO device
Yes,
that
sir. Yes.
still, yeah, that
Correct,
still
sir.
is working in the electrical and the optical switch are there.
Correct,
So
correct.
that's why it means when
Sir,
the in
that
general
parameter.
when it increase, yeah, in general when it reduce delay and operation faster, in general, in traditional way you have to sacrifice in terms of power. So
Correct,
that's why
sir.
I am asking how
Yes, sir.
much your power is
So
increasing.
that your point is quite justified, sir. Because as Rupaban sir also said that how to connect the memory devices. So it is your question also is connected with that problem also.
Yeah, yeah,
When
exactly,
we are considering the power consumption, we have to take the entire design aspects, that synchronization
exactly.
with all the modules to be taken care. Okay, sir,
Yeah,
we will surely work on what actually we are working on it, but sir, that is not complete. I cannot
okay,
exactly give you the answer. I apologize for that, but surely, sir, we
okay,
will look into it.
okay, okay, okay. Thank you, Arindam sir. Yeah.
Thank you, sir.
So, is there any other question? If not, then we can thanks Arindam sir for his nice presentation, and then
Thank you very much. All your patience, Swagata sir and Rupaban sir.
yeah. So now I call the next participant. The paper ID 52. 52. Name of the presenter is Genvia Charimang from Cotton University, and his paper name of the title of the paper is ML based PCB classification with Gabor and statistical features.
Hello, am I audible?
You are audible, okay, but your slide is not visible.
Okay,
Yes.
sir, let me share it.
Please say it again.
Yes. Is my slide visible?
Yeah, yeah,
Yes, but
yeah.
if it will be great if you can increase little bit the resolution, I think, or take it full screen mode. Yeah, yeah. Now it's
Yeah,
absolutely fine. Yeah.
Yes.
coming. Yeah, fine. So 10 minutes, okay? 10 minutes. 10 minutes
Yes.
totally. Please go ahead.
Good morning, everyone. My name is Genevieve Sharma, and my paper ID is 52. And the title of my paper is ML-based PCB classification with Gabor and statistical features. The outline of today's presentation, which we will discuss about, is introduction, overview, methodology, result, conclusion, and references. So first, let's understand what printed circuit boards and what are its defects. So printed circuit boards are the main functional building block of modern electronics, and their size varies from flash small drive to large model board depending upon their complexities. The tedious manufacturing process and other agents lead to various anomalies in the production line. Certain defects are found to be either irredeemable or cannot be repaired. So in printed circuit boards, we have divide the defective PCB into two classes, that is true or irreparable defects, pseudo or repairable defects. In true or irreparable defects are those defects which cannot be repairable. However, in pseudo or repairable defects are those defects which are developed due to weak rust or layer of dust on time with them, and this defect can be repairable with adequate and cheap process. So these are the image of defective PCB with both true and PCB defect. As we can see in the first image, which includes wear rust, which is of pseudo defects, and then second image is not connected, then connected independent thick rust projection, which is of true defects, and then we have dust, which is of pseudo defects, and then big rust, which of pseudo defects. So in this paper, we have proposed an algorithm for automatic optical inspection for classification of printed circuit boards that's into classes, the true, defect, and pseudo defects. So in this research, we have performed feature extraction from the real images of defective PCB, which we perform two kinds of feature extraction. There are two kinds of features, that is statistical features and Gerber features. Then, in order to ensure the efficient discrimination between the two classes of, that is Gerber and statistical feature, we have optimized those features. Then the statistical features have been selected on the basis of their maximum power to discriminate the texture, pseudo, and true defects, which we employ the Mahalanobis distance. So for classification, we have used a support vector machine in which we got an overall accuracy of 98.27%. So these are the literature review of some of the previous work. At Gohos et al. Have used transfer learning based upon VG16 pre-trained model where he performed classification of PCBs. At Zhang et al. He performed multitask SIN-N model to handle the multi-label learning by defining each label learning as a binary classification task. That at Ren et al. He performed the PCB classification by using a naive bias and meta class, in which he got accuracy of 96.2%. And at Raj et al., he performed the PCB defects into four categories, that is missing hole, pinhole, short circuit, and open circuit. And he performed using image subtraction method. And for feature extraction, he have used thresholding, and Hawk transformation. And at Core et al., in his work, he have used image subtraction method for finding the printed circuit boards. So the methodology in our proposed work is that we provide a defectless image with a defective image. Then we perform image subtractions. After performing image subtraction, we got the defect, the difference between the image. Then we apply Gable filters for feature extractions. After getting the features, we have normalized the value using zero means and unit variance. After that, to optimize the Gable filters, we have applied genetic algorithm by which a fitness function we try to minimize the accuracy and minimize the variance. After the genetic algorithm, we have performed using k-mean cluster to classify those data samples into two groups, that is group 1 and group 2. And in those data samples, we have applied statistical feature to extract the statistical feature. After extracting the statistical feature from those data samples, we perform feature selection, that is Mahalanobis distance. After getting those features, we have then normalize this value using zero mean and unit variance. Then we train the SVM in both the group. Then the output of this group, we analyze the performance of it and we get the accuracy of it. So for data generation in our methodology, we have collected the data from Chubu University, and then the total number of samples in our dataset is 1,164 samples which we carry out in this experiment. Out of which 882 samples are of PCBs with true defects and 282 samples of PCB with pseudo defects. As I mentioned earlier, the image extraction methods we have used. As we can see here, this is the defective PCB with defective image. And here is a reference image of it. And after image subtraction, we got the difference image. And for feature extraction, as is an important and crucial steps in pattern recognition for extracting the relevant information from the data samples. So in our proposed method, we employed two techniques, that is Gable filter-based features and statistical features. So in Gable filters, we have used these different parameters to create the Gable filter banks. That is the number of frequency, which is 4, number of rotation 4, frequency ratio, that is root square 2, and then smoothing parameter of 0.5. After getting the features, we use genetic algorithm to optimize the Gable filters to optimize the Gable filter. For statistical feature, for feature extraction, we have considered these features, that is average gray level, standard deviation, smoothness, entropy, uniformity, and third moment and gray level ratio. So for selecting the statistical feature and performing feature selection, we have used Mahalanobis distance, in which we measure the distance between class I and class J along a particular feature dimension group. And here we try to discriminate the power between two feature groups by having less correlation between two feature groups. The less the correlation, the greater is the discriminative power of it. So these are some of the statistical feature along with accuracy. We have performed on 20 random samples and these statistical features have been arranged in increasing order based upon their ability to discriminate between the two classes. That is, here you can see the accuracy increase from uniformity, smoothness, standard deviation to entropy. And we have performed classification accuracies and also with different feature set and classification algorithm. As here with statistical feature, the 7 feature with linear SVM, we got 94.22 accuracy. Then selected statistical feature. Here the entropy class is not included. The entropy feature is not included, and plus with linear SVM we got 94. However, we can see here that even without entropy, we got accuracy of the same. And the rest with other features combination, and we got this other accuracy we obtained. So in order to visualize the data sample, we have used a scatter plot. Here we have drawn the visualize and infer the relationship between the data samples. In her career research work, the scatter plot of the data sample are plotted with extracted features, that is the Gerber and the statistical features, by reducing the dimension using principal component analysis, and the PCA is reduced the dimension of extracted feature to principal components. So as we can see here in the figure 5, the scatter plot of principal component of various defect with statistical features. As we can see here that this pseudo defect big ras is far away from true defects. As we can see, true defect here independent, true defects projection. However, just one close to it versus the true defect mouse bite. And here is the scatter plot of various defect with anatomized Gerber features. And when we optimize the Gerber features, we can see here that we have marked the circle into two groups. That is group 1, which containing the true defects, as we can see here, the projection of true defect independent, and group 2, we have considered the pseudo defect as dust. So if we, as we can see that if we are able to identify the group first, it will be easier to classify the class into true defect and pseudo defects. So the accuracy we obtained after from the two groups, that is we have used two support vector machine classifier in group 1 and group 2, and then all of accuracy we got 98.27%. So we can conclude in our current research work that the Gerber features upon optimization can provide great resolution among kind of defects and statistical features. Then in our proposed algorithm, we have performed that clustering. Then we performed bulk classification. That is, first in the bulk classification, first one was where we divided into groups. After that, we performed the classification using SVM. So we overall we have seen that we have got accuracy of 98.27%, which is of highly satisfactory. These are the references. Thank you.
Now the session is open for question from audience.
Yeah, if any question from audience. So if the audience have do not have any question, I have one question to Genevieve. That
Yes, sir.
why you have chosen SVN directly? Means, is there any option? Because in general SVM may give good result, that's okay, fine, but the main issue is that it is resource is very high and computational complexity is also very high. So have you tried with the random forest or decision tree, anything?
Sir, as of now, this is the initial work. We started with SVM. We haven't it's still an ongoing work. So we'll try with other classifier. As of now, we have tried with SVM and we check what accuracy we got with SVM. We put it out.
Okay. So have you done any comparative analysis? Means because initially at the beginning you have illustrated some of the research going on in this domain
Yes,
in different papers. So have you
yes.
compared your result in terms of accuracy or confusion
Yes,
matrix
yes,
with
sir.
that
We
present
have
work?
compared with few of those work, and the accuracy we receive is comparatively higher to the previous work. As I mentioned here, some of them get 95, some of get 96, and compare our accuracy we receive higher to the previous work we have done earlier,
So what is your accuracy?
and 98.27, sir.
98.27. Okay. So
Yes.
is it these accuracy is for choosing the SVM model for that? They have also chosen SVM, or is it for the features that you have selected? Means why the
Uh,
accuracy is better compared to other works?
Other work mostly they employed either CNN. In this, except for one work who employed using image process that is auto thresholding and Hawk transform. In our case, we employed SVM for classifying the those after performing clustering and then extraction of the features. Then we perform the SVM to classify based on the features.
Yeah, that's okay. So means you are telling that the compared to CNN, your model is giving
Yeah.
the best better result. Means
Yes.
compared to deep learning classical approach giving the better result. In general,
Yes.
it doesn't work. In general, classical one gives the poor result compared to CNN because it is deep learning based
Yes.
technique. But
Yes.
okay, it may gives okay. So yeah, Rupaban sir, if you have any question.
Yes, yes. I have only one question, okay, regarding the
Yes, sir.
database actually.
Yes, sir.
So that means your data, whatever the PCB you have taken actually, okay, in your
Yes.
database, data from the same machine or different machine?
Uh,
Because it's a
sir,
manufacturing defect and all, na? It's all depends on
yes,
the,
yes,
it's in the, that means this production things, na? The defects and all, it depends on the, that means in the machine actually, okay?
yeah,
All
yes, sir.
machines are not having the same accuracy actually.
Yes. As of this, the data we collected is from Chubu University. So as of now, I'm not aware of all the whether the data has been collected from say a single source or different from different machine. That I'm not aware of, sir. That what data has been provided to us, we train on that data.
Okay, okay, that means
Means
data
you are
information.
using the synthetic data.
Yes.
But I think
Okay,
it will be better if you can try, just it is my suggestion that obviously you
Yes.
can try with the
Yes.
real data. Means after developed your data model with the synthetic data, just try with that model to check how much, to validate how it performs in real life. Okay, real data. Okay, as Sally
Yes.
is asking.
Yes, sir.
Okay,
okay,
so
Uh,
so
Thank you.
okay, so if no other question, then we thank Genevieve Chaimang, and then
Yes.
and then
Thank you, sir. Thank you, sir.
yeah, thanks. So we can proceed to our next participant. So paper ID 94, and the title of this paper is the capacity analysis over shadowed BX fading channel for various adaptive transmission scheme. And name of the presenter is Sisira Hawaii Bum. Yeah. So I am requesting Sisira to start this presentation.
Good morning, sir. Can you see my slide?
No, it is not visible. Please, your voice is clear, but your slide is not visible.
please share it once again.
Okay, sir. So, can you see my slide now?
No, it's not visible.
Yeah. Just go to the share.
Uh,
Yeah.
it-
Now it is visible. Absolutely.
Okay.
yeah,
Now
it's,
it's visible? Okay.
Yeah. Yeah.
yeah, it's
Absolutely.
visible. You are audible. Okay, you please start within 10 minutes. Okay, you please finish.
Okay,
Okay.
sir.
Ah,
I'm Sira Hawaibam and I'll be presenting on the title Capacity Analysis Overshadowed Baulizi Fading Channels for Various Adaptive Transmission Schemes. Here are the topics which I'll be talking about: introduction, literature review, motivation, fading channel, capacity analysis, numerical results, conclusions, and references. To start with, I'll explain what wireless communication is. It is defined as transfer or receive of information through electromagnetic waves in an open space. So in wireless communication, we can perform many performance metrics to analyze and study the behavior of a system. To mention some of them are outage probability, average bit error rate, effective rate, etc. And one very important performance matrix which I'll be analyzing is the channel capacity. So channel capacity is the maximum rate which we can transfer from transmitter to receiver with the least error. So some errors do exist in the wireless channel, and to reduce them we use different adaptive transmission schemes to improve the channel capacity. They are optimal rate adaptation with constant power, optimal simultaneous power and rate adaptation, channel inversion with fixed rate, and truncated channel inversion with fixed rate. So, the study of wireless communication with various other fading channels that exist in the literature is also a very popular research area. To mention some of the traditional fading models are relay, Ryushin, Nakagami M, etc. They describe according to different communication scenarios, and these traditional models they are not suitable for characterizing the emerging technologies like millimeter wave, 5G, and terahertz. And these technologies are very popular these days because they are able to provide high speed and data and capacity to the users. They demand feeding models which are flexibility have flexibility of a wide range of feeding parameters, and which can accommodate signal transmission through both line of sight and non-line of sight components. So recently, a composite model called shadowed Bowlesy fading model has been proposed in three, and it is suitable to describe these emerging technologies because it has all the features, and it overcomes the limitations of other fading models, and it has advantage like it can approximate other fading models like Bowlesy, Relay, Ryushin, Nakagami M, etc. It has also been validated as fit to describe for millimeter wave wireless communication system in 28 gigahertz band. It has also wider fading parameters. Now coming to the literature review, these are some of the literature which I have done. In three, performance analysis for average bit error rate and outage probability is carried out for SBX feeding model. There has been many works on capacity analysis for different feeding channel, which is given in 4 to 8, and capacity analysis for various adaptive transmission schemes for SBX feeding channel is studied in 1. So I have mentioned that in one, capacity analysis has been done for SBX fading channel, but for they have not compared and plotted graphically for CIFR and TIFR schemes for different fading and shadowing parameters. And as you know, for adaptive transmission schemes, CIFR and TIFR schemes are very important for implementing it practically. And the approach to evaluate the capacity under OPRA, CIFR, and TIFR schemes are different in this paper. Motivated by the lack of these works, I have done capacity analysis for the different adaptive transmission schemes for SBX fading channels, and it also includes the effects of shadowing and fading parameter on the channel capacity. Fading channel. So SBX fading channel is identified by 4 parameters, that is fading parameter, shadowing parameter, average power due to non-line of sight component, and average power due to line of sight components. It is derived from Nakagami and Bowlesy fading channels, and the line of sight and the non-line of sight components, they undergo different shadowing and fading severity parameters, and they're independent of each other. So equation number 1 gives the PDF, that is probability density function of the received signal to noise ratio for the SBX fading channel. And as you can see, this is the gamma function which I have defined, and the other parameters are also defined. Now equation 2 gives the cumulative density function of the received SNR for the SBX fading channel, and the respective parameter is also described, and this is known as the incomplete gamma function. Now the capacity analysis. So for CIFR, the transmitter, it supports a fixed data rate irrespective of the channel conditions, and it adjusts its transmission power according to the channel fading conditions. Like it uses huge power to balance the severe fading. So the equation number 3 gives the channel capacity standard formula for CIFR scheme. And the final expression which I have obtained for SBX channel, SBX fading channel, is obtained in equation number 4. Now TIFR scheme, as you know, in CIFR, huge amount of power is required to balance severe fading in the communication channel. So in CIFR, it overcomes this problem because it allocates the power only when the received SNR reaches a fixed threshold, which is defined as STH. So equation number 5 gives the standard formula for TIFR scheme, and to obtain the final equation we require PO, that is the outage probability, and to solve this denominator. So PO is the outage probability of the SBX fading channel, which is expressed in equation number 6, and S0 is the threshold level. Now from equation number 5, this term has been solved, and we can obtain the final expression of the TIFR for SBX fading channel by placing equation number 6 and 7 in the 5. OPRA. So in OPRA, channel state information is available only to the to both transmitter and receiver, and power and rate is adapted simultaneously. And equation number 8 gives the standard capacity for OPRA scheme, where STH denotes the cutoff SNR. So below this, the data transmission is not possible. Now equation number 9 gives the final expression of OPRA scheme for SBX fading channel. ORA. In ORA, channel state information is only available to the receiver, and constant transmitting power is there. And in this, transmission rate is adapted only according to the receiver's CSI. That is channel state information. So equation number 10 gives the standard formula for ORA scheme, and the final expression for ORA scheme over SBX fading channel is obtained in equation number 11. And this function is known as Major's G function. Now coming to the numerical results and discussion. Figure 1 gives the capacity analysis under CIFR scheme. In this, the graph is plotted for different values of fading and shadowing parameter as it is depicted in the figure. So as observed, capacity improves as we increase the value of fading parameter and as we increase the average SNR. It is also noticed that at the lower SNR value, shadowing parameter higher value of shadowing parameter does better compared to the lower values. This is because lower value of shadowing parameter represents heavy shadowing and less shadowing at the higher values. Figure number 2 gives the capacity analysis under TIFR scheme. This graph is plotted for different values of fading parameter with constant shadowing parameter. So you can see the difference between
Your
1
time
and
is almost finished. Huh? Wind up quickly. Your
Yes,
time
sir.
is almost finished.
Yes, sir. The difference between the fading parameter 1 and 4, you can see that there is approximately 1.5 bits per second per hertz difference. This is because the system suffers at the lower value of fading and improves as we increase the value. Figure number 3 gives the analysis for OPRA and ORA scheme. This is plotted for different values of fading parameter and constant value of shadowing parameter. As you can observe, at lower SNR values, capacity of OPRA performs better than ORA, as ORA is more prone to fading conditions. And the effect of fading can be decreased by increasing the value of fading parameter. Lastly, figure number 4 shows the comparison for the four adaptive transmission schemes. As you can see that the capacity of all the four increases with the increase in average SNR, and capacity of OPRA is superior than the other fading other schemes, because during severe fading, transmitter can transmit maximum power, and it is possible that all the signals may not be recovered, so it can consequently lower the capacity of the channel. Coming to the conclusion, in this paper, numerical expression for channel capacity for SBX fading channel were evaluated, and for four adaptive transmission scheme, which are CIFR, TIFR, OPR, and ORA, and the effect of fading and shadowing parameter were taken into consideration. The results obtained show that the capacity improved when we increase the value of fading and shadowing parameter, and among the four schemes, OPRA was better than the other schemes. And these are some of the references which I have used to make this presentation. Thank you.
Now we can take up some questions from the audience, if any. So if there's no question, okay, I have one question, Shreya.
Yes, sir.
How you are validating your results?
So I have not. I've just done the analytical analysis. I'll be validating with some standard measurements.
Okay. So my next question is that in your that is expression, okay, infinite series are present. Okay.
Yes, sir.
How you have done the calculations?
So you mean calculations like solving it
Your
theoretically,
expression,
or?
yeah, your expressions contain infinite series.
Yes, sir.
Okay. So how you have done the calculation actually over there?
Okay. So I have not. I have just taken like from some certain values like 0 to 50, 30 or something like that. I have not taken till infinity in the
Okay.
analysis.
Okay. Then how you will ensure that okay the remaining portion is not carrying any value?
So I can in the future I can check the accuracy for different numbers of submissions.
Okay. 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 So Swagata ji, if you have
Yeah.
any question, you may
Yeah,
ask.
Shishira, just one question that we have told that at the beginning that you have some literature review, we have shown that with some paper, but here actually your main contribution, as I have understood from your presentation, that you increase the capacity of the channel along with some parameter. Okay, am I right?
Yes, sir.
Yeah. So in the presentation in the last result section, you have shown some your result with some parameter increasing that you are using in the equation. So my
Yes.
question, have you means how much it is increased with the existing architecture existing systems, how much it is increased?
So I have used the shadowed Bauerzi fading channels for this analysis, but I have not compared it with other fading
But
channels.
I
I have
think
just
it
focused.
will be you should compare with some other existing work. Otherwise, how can you say that your work is better compared to or means better compared to existing existing system or existing proposal?
Yes, so that in the future I'll keep that in mind. I'll show it. I'll do the comparison to show that this analysis is better or worse than the existing ones.
Exactly. Okay. Okay. So any other question from audience? Okay. If not, so thanks Shishira for her nice presentation. So
Yes, sir.
thanks, thanks,
Uh,
thank you.
so my next one is also mine.
Yeah, yeah. Just I am calling you. So your next one is also for you. 95, I think your
Yes, sir.
95 paper ID. Yeah, next one is a performance comparison on LSC and LMRC over various fading channels. Okay, yeah, you can start. Yeah.
So is my screen visible?
No, no, not yet. Yeah. Now it's coming.
Now it's okay. Yeah.
Okay,
Yeah. Now
okay,
it's
I'm
coming.
starting. So the title of the presentation is Performance Comparison for LSC and LMRC over various fading channel. LSC like selection combining and MRC maximal ratio combining. So these are the topics which I'll be discussing. Introduction, literature review, work done, diversity techniques, performance analysis, numerical results, conclusions, and references.
You can give more
So
emphasis on your part, huh? On your A. And I'm just requesting you, okay, to complete it within time because uh,
yes, sir, yes, sir.
we are time bound actually. Okay, so we
Exactly.
have
We
to
have
start the
session.
other sessions timely.
Okay, so
So our time is
I'll
only. So
I'll
please
try to
be
finish it
precise.
first.
Yeah, be precise. Okay.
Okay. So in the parameters of a wireless channel in a wireless communication is unpredictable and it undergoes multi-part fading effects. These effects are reflection, diffraction, and scattering of the signals, and these can severely degrade the system performance overall in the wireless communication. So there are many techniques to mitigate these effects in the wireless communication, and one of the very popular technique is known as diversity, because it can reduce the effects of fading. There are many types of diversity like time diversity, frequency diversity, polarization, and spatial diversity. Spatial diversity, which I'll be doing in this study. So there are many types of models to characterize the behavior of multipart feeding envelope according to the nature of propagations. And these are the fading channel which I'll be using in this study, that is Rayleigh, Russian, and Nakagami M fading channels. So coming to the literature review, I'll just read out the literature review. In first, performances have been compared for CSC and OSC and MRC. It has been stated in the study that for same diversity order, asymptotic bit error rate has been evaluated, and it is found that MRC is the most efficient and CSC is the least. Millimeter wave communication with SC over FGR fading channel has been investigated in 2, and ASER for QAM with L branch MRC receiver in eta mu and kappa mu fading channel is analyzed in 3. Performance of for L branch SC in generalized Rayleigh fading channel with independent and identical distribution has been performed in 4. Evaluation of L-branch diversity for equally correlated region fading channel is presented in 5. SC and equal gain combining has been used for different modulation schemes for to perform ABR. Exact expression of ASCR for several coherent L-branch MRC in a set of correlated Nakagami M fading channel has been used to study the performance for MPSK or M-QAM in 6. Study in 7 emphasized on analyzing the performance of single and dual SC receiver with PSK modulation schemes in Rayleigh and Nakagami and fading channels. An experiment for SC technique over Rayleigh fading channel to reduce error during image transmission in wireless channel was performed in 8, and it was done for BER which showed that the system improved with diversity. So this is the work done. Performance comparison for Rayleigh, Russian, and Nakagami M fading channel with L branch SC and MRC diversity technique for the communication system are presented. Expression of outage probability and ABR with coherent modulation schemes are presented for the 3 fading channels. Binary PSK is used for the coherent modulation schemes. The performance of the stated channels are compared and plotted. And as per literature survey, this kind of comparison of the performance has not been familiar. Now coming to the diversity techniques. In diversity, several similar copies of signals are transmitted through different numbers of antennas, and they are all processed and combined at the diversity receiver. This is done so that the overall chance of fading over all the branches is reduced and increases the signal to noise ratio. In my study, two diversity techniques have been considered, that is selection combining and maximal ratio combining with L number of branches. So in SE, it is the least complicated as only one branch is processed. It chooses the branch with the strongest SNR among all the branches. Equation number 9 gives the SNR output at the SC combiner. MRC, all the signals from different branches are first co-phased, weighted proportionally, and summed at the combiner output. This gives the optimum output, but it is very complicated to implement. It needs to know all the parameters. And equation number 2 gives the SNR output at the MRC combiner. Performance analysis. So equation number 3 gives the ABR expression of LSC receiver for relay feeding channel for the binary PSK. L is the number of diversity branches and S bar is the average output SNR of the channel. Equation number 4 gives the ABR expression of LSC receivers for Rician feeding channel. It is obtained by putting all these equations. This is known as the hypogeometric function. Equation number 5 gives the ABR expression of LSC receiver for Nakagami M fading channel. M is the fading parameter of Nakagami. And A and B different values of A and B can be chosen for different types of modulation. In this, I have used binary phase shift keying, so the value of A will be 1 and B will be 2. Equation number 6 gives the ABR expression of LMRC for relay fading channel for coherent modulation, and equation number 7 gives the expression for LMRC for Rician fading channel. Question number 8 gives the ABR expression of LMRC for Nakagami M fading channel, and and 9 gives the outage probability expression for LSC receivers for the relay fading channel. Question number 10 and 11 gives the outage probability of LSC output SNR for Rician and Nakagami fading channel respectively. And equation number 12, 13 and 14 gives the outage probability expression of LMRC receivers for relay, Rician and Nakagami fading channels respectively. Now coming to the numerical analysis. Figure 1 gives the ABR for L branch SC. BPSK technique has been used because it's one of the simplest form of PSK. As you can observe, for branch L2, that is 2 and 3, Rician does the best compared to the other fading channels. As you can see at M equal to 1, Nakagami suffers from fluctuations and the error increases, so the performance is poor for Nakagami M fading channel. And performance over relay with L equal to 3 and Rician with L equal to 2 are very close to each other. It means that the error rates are almost same. Figure number 2 gives the ABR for L branch MRC. As you can see that at L equal to 2 and 3, relay channel decreases the most. That means this performance is the best for relay fading channel because the possibility of interference and distortion over the channel is reduced. Between Rician and Nakagami M, Rician performs better and Nakagami M suffers from deep fading at M equal to 0.5, affecting the performance of the system. Figure number 3 gives the outage probability for L branch SC. Rician fading channel has a strong line of sight component between the transmitter and receiver and makes it perform the best at L equal to 3. And it'll be very, this is the best because SC is able to choose one branch from all the other branches. Next, Nakagami M with L equal to 3 performs better than Rayleigh, and it has been seen that Rayleigh with L equal to 2 and 3 degrades the system performance. This is because Rayleigh feeding channel has no dominant component along the line of sight between transmitter and receiver, and it is difficult for SC to choose a branch with highest SNR. In figure number 4, outage probability for L branch MRC is given. It has been seen that Nakagami M and recent fading channel are very close. For L equal to 3, it is advantage for the system to make outage at the lesser values, and they perform almost equivalent to each other with Rician. At L equal to 2 and L equal to 3, Rayleigh performance of Rayleigh degrades the most as it undergoes more fading. Coming to the conclusion, this paper shows the performance for Rayleigh, Rician, and Nakagami M fading channel, and ABR for coherent modulation, that is BPSK, and outage probability have been evaluated for L branch diversity, and the techniques used are selection combining and maximal ratio combining for the analysis. Diversity is used because it exploits the multipath channel and it can lower the deep fade in the system. The results show that the fading parameter M and K affect the system and shows the importance of diversity in communication. It has been concluded that when diversity branch increases, performance improves, and MRC diversity is favorable as it gives good SNR gain. So these are some of the references which I have used. Thank you.
So thank you, Cecilia.
Thank you, sir.
We can take up some questions from the audience, if any. See, no, okay, I have one question.
Yes, sir.
Okay, in this particular work, basically you are comparing key fading channel
Yes,
and their
sir.
performances, what I have observed.
Yes,
So,
sir.
what are the parameter you have chosen actually for that means Nakagami M fading channel?
So for different figure, for different analysis, like for LSC, LMRC, and outage and ABR, I have chosen different parameters. Like I have not
So
chosen
what
a
is the
fixed
M
one.
you have taken for Nakagami M channel? M
M I
value.
have taken 1, 2, and 0.5 for different figures for
Okay.
different analysis.
So M equal to 1 is relay, na?
Yes, sir.
Then already you have considered relay fading channel. Why both the value you are taking? That I am not understanding. Okay.
Okay, so I have
My
taken
second
M
point
equals to 2.
Yeah, my second point is that okay, you have mentioned that okay, the Russian is performing better okay in one particular channel and in one particular figure, and
Yes.
in another particular figure you have shown Nakagami M is better. It's because of the parameters actually. Okay, if you choose the
Yes.
parameters, if you take different
Okay.
parameters, the performance will be different actually.
Okay, sir.
Okay.
Okay, sir. So should I change the parameters and make a comparison again?
Yeah, actually that should be done. You cannot say that way actually that this Russian will always perform better. That you cannot say. If
Okay.
suppose the line of sight part, if suppose a weak signal is coming, in that particular case, it will not perform better way, no?
Yes, sir. It's because of the recent factor and feeding parameter which I've chosen. It's
Okay,
because
okay,
of that.
okay. Anyway, that things you please look after, okay? And
Yes, sir.
I'm just handing over to Swagata okay?
Yeah,
Because we
yeah,
are
sir.
running.
Yes.
No, I don't have any question for this presentation.
Okay.
So,
Okay, sir.
so thanks, Jay. If no other questions, so you can ask our next participant to present. Thanks,
Yes, sir.
Ishira, for your
Thank
nice
you so much, sir.
presentation. Yeah.
Thank you, sir. Thank you, sir.
So next participants, please.
Yeah, so our next participant is Shubhoproto Dhar, paper ID 132, a learning model for channel selection and allocation in cognitive radio network.
Okay, sir. Yes, but was it audible or not, ma'am? Was it audible? My
Yeah,
voice is
your voice
audible.
is coming.
Yeah, you are
Okay,
audible,
okay,
but your
okay.
screen is
Okay,
not
my
visible.
screen is not shared. Okay, okay. So I'm just sharing my screen.
Yeah,
Uh,
please share your screen. Yeah,
okay,
you are
okay,
audible.
okay, okay, okay. I'm just sharing. So my topic is running based module for. Okay, here I think my phone computer like this. Sir, how to share over here? I'm just share screen. Okay, share screen.
Yeah, share screen is
Okay,
there.
okay, 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 okay. Sir, my topic is the running based model for channel space allocation cognitive radio environment. So I'm just doing full. So full. Okay,
Make
so
it
my
full
topic
screen. Yeah.
okay, yeah, my topic running model for channel station allocation cognitive radio. Okay, so my topic, my first of all, I want to tell about cognitive radio technology. What is cognitive radio technology? So the overview, the background of the cognitive radio technology, the objectives of the research, description, and the solution, and the uh, conclusion and result. So I'm just first of all I will take out the background. What is a cognitive radio and the importance of channel station cognitive radio network. So cognitive radio network is technology that can learn from the sound radio frequency environment. The main function of the cognitive radio technology is just sense the environment, learn from it, and take decisions about the spectrum, whether use the spectrum or not. So the quality radio technology decide whether the spectrum is busy or the spectrum is free. Suppose the I just want to show in the paint section so that I can just close into. So quality radio consists of two kind of primary user and secondary user. So the primary user has full access to, has have full access to access the whole spectrum, primary user, or whereas the secondary user cannot access the whole spectrum. Secondary user we just write as SU and primary user we just write as PU. So primary user has full access to the access to access the whole spectrum, or the secondary user unlicensed spectrum cannot use the whole spectrum. So sometimes in case of cognitive radio, the main thing that cognitive technology it just sense the radio frequency environment, learns from it, and take decisions whether we can use the spectrum or not. So by using various sensing technology, it take decisions. So for this reason, the interference and jamming problem can be overcome by the help of CI radio. So if the interference problem can be removed, quality of service can be improved. So this is the cognitive radio technology. Next we move to the next slide. So this is the architecture of the cognitive radio technology. Architecture means I have already told primary user and secondary user portions. So primary user, licensed user has full access to use the whole frequency spectrum, or the secondary user, unlicensed user cannot use the whole frequencies. For this reason, sometimes the secondary user reappear. Secondary user try to use the spectrum. Their interference takes place. Okay, so interference takes place to reduce this interference problem and jamming problem. We are using channel selection technology. So importance of channel selection cognitive radio. So channel selection plays a vital part in uninterrupted and efficient communication. So I have already told you that unlicensed user or secondary user has full access to use the spectrum. Okay, but sometimes the unlicensed user or secondary user opportunistically try to access the whole uh, channel spectrum. So interference takes place between Q and SU. So for reduce this interference problem and the jamming problem between this user, we are using the channel selection allocation technology. Okay. Next we move to next. So proposed scheme, the objectives of our research to the reduce the computational delay to efficient channel selection. Means we to reduce the delay problem. Delay problem is a major challenging problem in our communication. To reduce the computational delay, so
we are just implementing the learning model. So the next point, we have to mitigate the transmission delay. Transmission receiver and transmitter. The transmission delay problem can also be reduced by the help of quantitative technology or translation technology. So by the translation technology, we can just enhance the accuracy of our model. Description: why does learning based challenge selection? Why this selection? So learning based challenge selection. So I have already repeated. I told in the previous slide. So sometimes primary user reappear in the channel during the SU transmission. So the secondary user cannot identify whether the primary user is present or not. So due to this thing, so there is a huge interference between the PU and SU. So to avoid this interference problem, so challenge selection is allocated based on past learning experience. So the spectrum the learns from the past experience. Past experiences mean that it is trends and learns from the past experiences. So the cognitive communication is basically the main thing is it can senses cognitive technology. It first of all it sense. First of all, I'm just writing, I'm not writing. It says, adapt, and learns from the environment. So learning is important over here. So the learning after learning from past experiences, the channel can decide whether the spectrum can be used or not. Okay. So our proposed solution. So, so over here we are implementing integration model, in short KDP model. So we are just considering one spectrum, in different time slot, one spectrum. So by the help of this model, we can just select whether the channel is free or channel is busy by the learning technology. So the simulation has been performed for single channel. I was performing single channel in different time slots. So in this model, we have just considered if the threshold error lies within the considered limit. Threshold error is lies within considered limit. Then the spectrum channel can be considered as a free channel or busy channel, depending on the error. Okay. So, but sometimes a high signal to noise ratio, when the signal on a SNR is very high, sometimes the secondary user fails to identify whether the primary user is present or not. Therefore, we're implementing the fuzzy C-means clustering algorithm that can perform better under better less not ratio. So this fuzzy seamless clustering algorithm can improve the accuracy of the learning based model. So this is a fuzzy seamless clustering algorithm. So fuzzy seamless clustering algorithm is basically clustering technique. So cluster can be formed, and depending on the center, this point is centered. Okay, so depending on the distance between data point and this point centroid, the algorithm decides whether the accuracy can be improved or not. So depending on the distance between the point and this centroid, the fuzzy C algorithm decide whether to use the spectrum or not, whether performance is good or not. So over here, channels is considered into categorized clusters. Okay, so fuzzy membership in the fourth point, we can see the fuzzy seed membership value varies based on the Euclidean distance data point and the center. I have already told the distance between the center. If the fuzzy membership value lies between 0.5 and 0.6, then it can be considered as a good value. Okay, so objective function parameter can be also reduced. Okay. Next is our result analysis. So we have considered, we have plotted two lines. We have plotted time slot and signal indicator RSSI and analyze each time slot. So over here we have decided we have to observe the behavior of a single channel in 18 time slot. Over here we have just observed the threshold error means the vertical distance between data point and this line, base field line. So distance we have considered the threshold error with 2 dBm. So the from analysis, the time slot 5, 6, 7, 8, 11, 12, 14, 16 are allocated suitable allocation, since the vertical distance between this base field line and data point is less than 2 TVM. Okay, okay. So the next we continue. We have further verified the accuracy of the proposed model by applying 80 RSI value as training model. So iterations have per 2000 times to obtain accurate result. Okay, here was adjusted. So by we have further verified the accuracy of the model by training data, by training by this problem, learning based technology. So accuracy enhancement by using FCM, accuracy enhancement. So we have the mitigated channel interference problem in network. Fuzzy seamless algorithm as implemented. Here channels in each time step are divided into cluster. We can see the cluster 1, cluster 2, and this point the center. Okay, so from this figure we have just shown the good value. So I've already told that membership value 0.5 to 0.6 is considered can be considered as a good value. So from the figure, the point this point receive signals indicator, this the center and this point is very much less. So you have considered those point. So those point the membership value is all this 0.537, 0.6221, 0.635. So by applying this FCM for the sequence clustering algorithm, we have just improved the accuracy of the FCM algorithm model, accuracy of the model. So conclusion, we have this learning based channelization has incorporate paper to enhance the performance of the radio network. By using the proposed ADP model and FCP algorithm, prediction accuracy has 99.1% so we have improved the prediction accuracy to this value. So in the future, the proposed model may be implemented for successful deployment of orthogonal based 5G conditions. So we are just planning to just in the future proposed model implementing 5G technology. So we are just planning to do all these things. References. Thank you, sir. Okay. Any questions regarding?
Yeah. Subadar, are you listening me? Hello?
Yes, sir.
Yeah,
Yes, sir. Yes, listening.
Okay. So now this session is open for question answer. So I think that from the presenter side, the microphone is mute. Okay, may not be any question from their side. So let me ask you one question. Okay.
Yes, yes.
So your problem is very appropriate actually. What the problem you have taken, because the channel selection is the most important actually aspect of cognitive radio.
Yes.
But in this particular case, actually, what parameter you have considered? Okay, that you have not mentioned. Generally, the power is being measured, and depending upon the power, okay, the cognitive radio decide okay whether the primary user is communicating or not. But in this particular case, what parameter you have considered for this learning process? You are considering power or something else?
No, we have considered receive signals indicator RSSI. We have considered RSSI receive signals indicator RSSI value. We have considered in our model RSSI.
The band is okay. I'm
RSSI.
not talking about the band. I'm just discussing about okay, what parameter you have considered. That means whether the primary user is present or not. That you need to decide, is not it. And for that
Yes,
you are
yes.
doing the learning algorithm. You are using the learning algorithm for that.
exactly. If primary user present, then you have to vacate the channel. So that's why you have
Yes,
to
yes.
measure the power, or sometimes you can
Power.
measure
Power.
outage probability or something like that. So as
Yes.
said, asking this is a very valid question. Is what are the parameters that based on which you select the channel? And how,
parameters.
suppose if the primary user present, then how you vacate?
Hmm. So
That
primary user, yeah, we have to consider over transfer power. We have not considered in this work. We have considered RSI value only, by the help of this technology, and we have considered signal to noise ratio. Signal to noise ratio we have
Okay, that is the
considered.
signal
So
strength only actually. Okay.
signal noise ratio, sir. In case of high SNR value, we are just implementing this model actually.
So what
In
kind
high,
of noise you have? What are the statistics of the noise you have chosen here? Is it a Gaussian noise or any particular kind of channel you have chosen?
actually, sir, in this work, we have considered any. We have considered the best. Issue. So we have
No,
considered the
suppose
best
when you
value,
simulate,
spectrum,
so
best spectrum channel.
in which software you have used for simulation purpose? MATLAB or any other?
Oh yeah, yeah, MATLAB.
Okay, so when you have chosen in the MATLAB, you have to give the particular statistics. Whether in the is n, you have to either you have to choose the white Gaussian noise in general n by 2 statistical distribution or Rayleigh Bayesian. What type of channel you have chosen? Because based on the
Cha-
channel characteristics, it your statistics will change.
radio frequency channel. We have considered frequency
No,
channel.
radio
RF
frequency
channel.
is okay. Every channel
Ah,
is the radio frequency channel. That's
ah.
okay. But I am taking which kind of channel, what kind of statistics you have chosen. Means what kind of distribution does it?
Gaussian characters, Gaussian
That I
noise
am asking.
characters,
Okay,
Gaussian characters is
okay, okay.
that.
Okay,
Okay.
sir. We can proceed now because we are running out of time also.
Yeah, 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 yeah.
Yeah. Okay.
So
We
the
are
next, yeah,
supposed to.
thanks, Shubhabrata sir. So we go for the next one, next participants. There is Tapos Chakraborty, paper ID 44, text and language independent classification of voice calling platforms using deep learning. Yeah. So yeah, Tapos sir, you can start.
Hi, so let me share my screen.
Yeah, please share your screen. Yeah, audible.
Okay, so can you see my screen?
No, not yet come. Just wait for a minute. Let's see.
Your audio and video is on, but please share your screen.
Uh, I have already shared.
Then you redo the things. Please reshare it.
Yeah, done.
But still not visible. Yeah, I think in another screen it is coming.
Yeah,
Yeah,
yes,
now
come.
it is okay. Yeah, yeah, yeah. Now it is okay.
Oh,
Yeah,
Yeah. We could able to
start.
see it.
okay, so my paper ID is 44, text and language independent classification of voice calling platforms using deep learning. So today I'm going to tell you a very interesting research topic, that is the classification of platforms. So after lockdown, the use of conferencing apps increases significantly. So we use not only for our remote work, but also for keeping social relations. So WhatsApp call, Google Meet, Zoom, mobile conferencing calls, they are very common today. Present situation demands understanding of these platforms. So the question is, given an audio file, can we identify the conferencing app used to record that audio file? So for our study, we have considered mobile conference call, Google Meet, Zoom, and Discord. The first step is the data collection. Then I will talk about the challenges that we face. Then the audio signal processing steps, uh, models and parameters. Then I will talk about results and discussions. So this is what I'm going to present today. The first is the data collection. So audio data was collected mainly from the following apps, as I told you earlier: the mobile conference call, Google Meet, Zoom, and Discord. So I have given a distribution of the data. So you can see here that Zoom recordings are most, then we have Google Meet and mobile calls, and we have very few Discord recordings. So in total, we have considered 100 audio files, each of duration approx 5 minutes, and it was recorded using the device of one of the participants. So how a sample is uploaded in one of the forum. You can see the link in the reference. So what happens? Various users, they call each other via Google Meet or Zoom, and one of the participants recorded the call. Then we considered that for our analysis. Next is the challenge. So in this particular audio call, we not only have the platform specific information, but we also have environmental noises. Various devices has been considered for recording the call. So there is a device mismatch. So there is a style mismatch also. Sometimes various persons actually spoke during the call, and they spoke in various languages. So in our audio files, we have platform mismatch as well as environment mismatch, device mismatch, style, and language mismatch. So the things are challenging. And also, I will like to highlight one more challenge that we face, that some of the conferencing apps doesn't allow recording. Let's say for WhatsApp, there is no inbuilt feature for recording the voice calls. So some third-party apps are there, but we avoided WhatsApp for now. Maybe in future we can think about considering it. Now I'm going to show you the block diagram of the platform identification. So during the training phase, we have given the audio of known platforms. So we have the audio file and we know the platform that has been used to record that audio file. Then we follow the signal processing steps to generate the log spectrogram. So this figure clearly indicates how a log spectrogram looks like in our case. Then we train the model and develop that model. So in our study, we have used two variations of convolutional neural network. One is ResNet, and the other one is DenseNet. Now the next step is validation. Here we have the audio file of unknown platform. So here the audio file is given as input to the model without the label. Again, we follow the same signal processing steps, generate log spectrogram, and then provided it as an input to the model. So log spectrogram is the input for the deep learning model. During validation step, we note down the accuracy. If the prediction matches, we will increase accuracy, and at the end, we will note the accuracy of the process. Now I will talk about the signal processing steps, what has been used on top of the input audio signal. So input audio signal is passed through a high pass filter to increase the amplitude of the higher frequencies. It also removes the low frequency noises. So the first step, pre-emphasis, what it does, it actually increases the amplitude of the higher frequency and removes the low frequency noise. The formula is given here. Here alpha is a parameter and we choose it as 0.97. The second step is silence frame removal. So when we get an audio file of 5 minutes, there could be some voice region where the people talk to each other. There could be some non-voice regions where nobody interacted with each other. So usually we need to remove the non-voice regions because they are not at all useful. So we remove the non-voice region. Here is the formula. We calculate the energy of each frame and we ignore all the frames whose energy is less than certain threshold. This is how we have removed the non-voice region. So initially the duration of the call was approximately 5 minutes. After removal of non-voice region, it may come down to 3 minutes or maybe 3.5 minutes. That is variable. We don't know the actual duration of the audio file after noise removal. Then what we did, we generated the log spectrogram. So for each of the 5 seconds duration, we generated one spectrogram. Here you can see 4 spectrograms. The first one is from the Zoom call, second one from the Google Meet, third one from the mobile, and fourth from the Discord. Now, if you look at the spectrograms carefully, you will see that mobile calls, they do not record high frequency components, and more or less we are able to identify the platform just by looking at the spectrogram. So this is something interesting. So platform specific features are there in the spectrogram. Now the question is whether the model will be able to detect that or not. So in our purpose, we used DenseNet and ResNet. So here I have given a image of DenseNet and the parameters that we have used for DenseNet. So DenseNet 201 has been used. Input shape of the spectrogram is 224 cross 224 and 3 channels are there since this is a color image. Output classes, obviously 4, Google Meet, Zoom, mobile conference and Discord. We have used average pooling, categorical cross entropy loss function was used, optimizer SGT, and here we use the metric accuracy to evaluate the performance. And yes, we do use the learning rate and momentum component. Their values are given here. Now, if you see the results, so the Zoom, we got 99.76% for DenseNet and for ResNet 99. Google Meet, both of them, we got 100%. Mobile call, we got 100 in DenseNet and 97 in ResNet. Discord, the performance is a little bit poor, 92%, and the overall accuracy we achieved is 99.72. So this is quite high. Now we want to evaluate the performance of the model that we have developed. So you see here, we have so many samples for Zoom. So that's what it's the color is light.
Suppose just one interruption that you should means how much you will time take because already you're 10 minutes over. So I think
Just 1 minute. I'm done. So if you see that the confusion matrix showing diagonal elements as a higher number of values and very few misclassifications happened here. So which indicates the model performance is also good. And the conclusion is, yeah, present situation demands understanding of these platforms. It can be used for forensic analysis. And in future, we will include other conferencing apps also. These are the references that was used here. Yeah, I'm done. So any questions? Thank you.
just I have one question, Tapo. So, why you have chosen these two, ResNet and DesNet? Any reason? Means AlexNet, GoogleNet. Have you tried with that?
No, we didn't because these are the most popular nets, and DenseNet is the
So
recent.
ResNet. How many layer ResNet you have used? 50 or
It's standard
90?
ResNet 50. Yeah, yeah.
Okay. Means have you tried with reducing the ResNet layer or increasing it? Means have you
No,
optimized it?
since the accuracy is high, we didn't do those
No, it
options.
may happen that if you reduce the number of layers, sometimes it may happen that accuracy remains same, But because when you increase the layer, your complexity will increase and resource consumption will increase. So I think you should try with reducing the number of layer also. Try with it.
Yeah,
See.
maybe we can use our own custom model also,
Yeah,
just
that is.
by 2 layers, or maybe. Yeah,
Yeah,
this
yeah.
is a good suggestion. Yeah.
Okay. So, sir, if you have any question.
Yeah, I have just one question actually. Okay, that application part actually. Okay, where your system will be applied actually.
So as I mentioned, it can be used for forensic purpose. So let's say in a particular Zoom call, one person was there who is actually a suspect. So maybe in that case, Zoom call can be, if you have the recording, it can be used for that. So it's mostly because the current situation demands the understanding of this platform, and this is the first time uh,
Yeah, yeah,
a,
that is true. Okay, what
a
you are
research
saying,
a
yeah, I
research has
agree with
been
you.
done. Yeah.
That I agree. Okay, but the application part actually, okay, I'm having some let me see. What you are saying is it's correct. Okay, that for understanding actually this type of analysis is required. That I fully agree. But as far as this forensic is concerned, okay, lot of validation will be also required actually. Not
Yeah, a
only
lot
this
of validation.
model, lot of other validation will be also required. Okay, before using as a forensic proof actually, because they
Correct,
need
correct.
some more thing actually. Okay,
Yeah,
not only this. Okay, so that's the thing. But anyway, okay, hats off to you that you have taken a challenging task and a completely new idea. That idea is completely new. Okay.
yeah.
Uh, so Swagataji, can you wind up this particular session? We are
Yeah,
coming to
yeah.
the end of this particular
Yeah,
session.
so we are coming. Yeah, thanks, Tapus, for your nice presentation. So we are at the end. So thanks every participants present here for the nice presentation. We conclude wrap up this session, and thanks Rupaban sir and to access session chair, and we proceed to our next session, and I think already next session has started already. So we are request the participant to join there. Okay. So thanks everyone. So again, so we are leaving from this session. Thanks everyone.
Thank
Thanks
you.
all.
Bye.
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 We have come to the end of this session. First of all, I would like to thank all the presenter for their hard work and contribution. And a special thank to the session chair, Professor Rupaban Subadar and Dr. Swagat Mandal, for being here with us and hosting the session. We will be joining shortly for the next session after some time. Thank you.